Hi all, today's LeetCode daily challenge problem is string compression 2. Run length encoding is a string compression method that works by replacing consecutive identical characters repeated two or more times with the concatenation of the character and the number making the count of the characters length of the run. For example, to compress the string AA, B, C, 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 we replace AA by A2 and replace C, C, C by C3. Thus, the compressed string becomes A2, B, C3. Notice that in this problem, we are not adding 1 after a single character. Given a string S and an integer k, you need to delete at most k characters from S such that a run length encoded version of S has minimum length. Find the minimum length of run length encoded version of S after deleting at most k characters. Example input 1 AAA B CC C D k equals 2. Compressing the S without deleting anything will result in A3B C3D of length 6. Deleting any of the characters A or C would at most decrease the length of the compressed string to 5. And if we delete B and D, the compressed version of the S will be A3 C3 of length 4. So 4 is output because any other way of deletion will not be optimal. In example input 2, we are allowed to make two deletions. There are two B characters and all other characters in the string S are A's. So if we delete both B's, the compressed string will become A4 of length 2. So 2 is output. In example input 3, K equals 0. So we can't delete anything and the compressed string A, A11 of length 3 is optimal and hence 3 is output. Constraint is such that length of the string can be between 1 to 100. K can be between 0 to string length. S only contains lowercase English letters. It is easy to see that brute force solution will be exponential and won't pass in the time limit. So the idea is to notice that there is a dependence on subproblem for solving the problem. So the subproblem is if we consider the substring from string I from index I to end of the string and k number of remaining characters, we can build on top of the result and get the final answer for the entire problem. Alternatively, we can also consider the substring starting from index 0 to end index I. But here in this problem, I have considered the substring from index I to end of the string, and I have used top-down approach of dynamic programming. Yeah, so the problem can also be solved using bottom-up approach, but the top-down approach is easier to explain and it is more intuitive. So first we notice the number of state states required. So there can be up to k deletions. So we can either we can delete zero characters or delete all the k allowed characters. So in total we can use k plus 1 positions for indicating the number of characters deleted, and obviously there will be n positions required to indicate the start index of the current substring for the subproblem. I have used box integer because by default it contains null value if the value is not set. If if I use the primitive, uh, I would just use I will just prefill the array with -1 or some other value to indicate that the subproblem is not calculated. Let's see the recurrence step of the top-down approach. First, we consider the base case. If k is less than 0, it means that we have used more number of deletions and reached this particular subproblem, and that's why k for this particular subproblem is received as a negative integer. In that case, we will return the maximum value as answer. So this subproblem uh, can never be subproblem with negative number of allowed deletions can never get considered. Here, the answer can't be greater than the length of the original listing, so I am returning n. Next, we are checking if the number of allowed deletions is already greater than the number of remaining characters. So in that case, we can simply delete all the characters, and the substring for this subproblem will become empty string, and it will have length 0, so we can return 0 in that case. Next, we are checking if the subproblem is already calculated. So in that case, dpij will be other than null value, and we can just return whatever is stored in the dpij. Next, we are initializing answer for the current subproblem, and answer the maximum value of the answer will be n minus I minus k. N minus I is the number of characters in the current substring, and k is the number of allowed deletions. So we can delete k characters, and that will be the length for the optimal answer without compression, without using compression. Next, if we try deleting the current index character at current index, we can recur for the subsequent subproblem with starting index I plus 1 and remaining k minus 1 characters. Now we have initialized length equal to 0, length same and different as variables. So length will indicate the length of the current run length encoded string of the current starting from index I to j. j j is initialized from I to n, and it will be done until diff becomes k. So the idea is to try deleting diff number of characters. So same will be the same will be the number of characters which are same as char at index I. Diff is the number of characters which are different than the char at index I. Now we are incrementing the length of the current run length encoded string by 1 every time we encounter one of these values. So basically, if okay, okay, so for starters, when j itself is I, same as I, then it will just uh, it will just introduce a new character, which is the current character. So length of the run length encoded string will increase when when same becomes 2, then we are introducing one digit. When same becomes 2, no, same becomes 10, then the digit to indicate the run length encoded number will be of length 2. So 10 is of length 2. So from A9 to, for example, A9 to A10, we are incrementing one length, and similarly from A99 to A100, we are increasing the length of the run length encoded string. So we are incrementing it here, and for each j, we are considering if the current run length encoded string after deleting diff number of characters, if this particular solution results in minimum answer or not for the current subproblem or not, mm, we are setting the answer accordingly. So minimum for each j is stored in answer, and finally we are setting that to current answer for the current subproblem indicating which is stored in dpij. Finally, we are returning that as answer, and after all the subcolumns are executed, the solve is 0k will return the answer to the entire problem. So that concludes our solution. Let me just resubmit to show you that the solution actually works. Yeah, so you can see that it is accepted. Thank you all. Let me know if you have any comments.